So these are functions and their graphs. This is the definition of increasing. A function is increasing on an open interval I if f of x1 is less than f of x2, whenever x1 is less than x2. Here's the open interval if x1 is less than x2 and f of x1 is less than f of x2. It's an increasing. An increasing function rises from left to right. We always read a graph from left to right to decide if it's increasing or decreasing. And we always, if we want to know where the function's increasing, we always use x values. So we'll go over that. A function is decreasing on an open interval I if f of x1 is greater than x2 whenever x1 is less than x2. So there's the picture. Here's the open interval I, and x1 is less than x2. You can see it's falling. The function's falling from left to right. And a function is constant on an open interval if f of x1 equals f of x2 for any x1 and x2 in the interval. So that's the definition of increasing, decreasing, and constant. And those are the pictures from the book. And when we're describing the intervals where a function is increasing, decreasing, or constant, we use x coordinates. Okay. Okay, and now we need to talk about the definition of a relative maximum and a relative minimum. A function value f of a is a relative maximum of f if there exists an open interval containing a such that f of a is greater than f of x. So here's a picture. We're talking about f of a being a relative maximum, and if we can come up with an open interval I and all our f of x's in that interval are less than f of a, then f of a is a relative maximum. So the infinities are not relative maximums or they're not maximums or mins. Because you can't come up with an open interval I around infinity. You can keep finding a bigger number to positive infinity. So this is the definition of a maximum. So the infinities are not included. Okay, and I fixed this typo. If you watch the integrity, I had to change this to a less than sign, but I fixed it. Changed these notes. So a function value f of v, here's a picture, is a relative minimum of f if there exists an open interval containing b such that f of b is less than all the f of x's around it. So if you can come up with an open interval around this, you know, from here to here, say, f of b is less than all the f of x's in here and here. And it's pretty obvious where the relative minimum is. But minus infinity is not a relative minimum. Okay? Okay, so you need to be able to look at a graph, and when the graph stops at the end of the grid without an open circle or a filled-in circle, it's got arrows on it. So just draw those arrows. So this is practice, and this you have to do some of this for the sheet. So determine where the function, that's the x values. And we want to write them in interval notation. Determine where the function is increasing, decreasing, or constant, and the numbers at which the function has a relative maxima or relative minima. Also state the domain and the range of the function. Okay, so we're looking for increasing. We look at where the function is right. Look where y is rising for increasing. But then you have to read the x values. And we will always use, for increasing, decreasing, and constant, we will always use parentheses, not the square bracket. Because at the endpoints, it's changing, and you can't say it's increasing or decreasing there. So we're never going to include the endpoints for increasing, decreasing, and constant. So increasing. So I'm going to start marking this up. This function is rising here. It's rising left to right. It's rising here. So for this interval, you look down and read the x value where this started rising was -4. So that's -4, comma. Then you go to where it stops rising, and you go back and you look at the x value. That's -2.5. That's -2.5. This means it's increasing when x is between -4 and -2.5. That's what that means. Next one. It's increasing here also, so you can put a comma or a union. It's okay. -1. So it's increasing when x is -1, and this is going up at an angle. So when x is going to infinity here. It's increasing to infinity. Okay, so those are the areas where it's increasing. Where is it decreasing? So you look at where where y is falling, where the graph is falling, but you need to read the x values, so it's falling here and here. So this is going up at an angle, but it goes to minus infinity on x. So from minus infinity to -4, it's decreasing. Okay, it's also falling from -2.5 to -1. These are the answers. Okay? And there's no areas where it's flat or constant, so put none there. When they say the word at here, they want the x value. When they just ask for a relative maxima, they want the y value. Is, or leaving that off, they want the y value. So the relative maxima is not the positive infinity up here. It's right here. The x value is -2.5. The y value, the actual maxima, you read it back here is at 5. Relative minima, so here's the two minimums. So those are the x values are -4 and -1. Is the y values, and they're the same. They're 0. You look back and they're at 0 here. All right, and then the domain. Now we can't hardly see my picture anymore, but okay. To find the domain, you project the graph to the x-axis. The domain is the values that x can take on. So you project graph to the x-axis. So we're going to project it to the x-axis. It goes to -infinity this way. And to positive infinity this way. So the domain on this graph, because it's going up at an angle here and here, is -infinity to infinity. What's the range? Now we're going to project it to the y-axis. So we project this to the y-axis. It always takes on the value of its vertex. So we're projecting to the y-axis. It's going to take on the 0. This is at 0. There's no open circles there. So, and this goes up to positive infinity. So the range, and you want to say square bracket because it includes 0 to infinity. And I projected the graph to the y-axis. Okay? Any questions? All right. So now we're going to go over even and odd. The function f is an even function if f of minus x equals f of x for all x in the domain of f. So we have to use this definition to show that a function is even, or show that it's not. And then a function f is an odd function if f of minus x equals the opposite of f of x for all x in the domain. So we're going to identify these as even, odd, or neither, and we're going to show work algebraically using this definition. So first off, we want to check to see if it's even. Well, we have f of x. We want to check this definition, so we're going to find f of minus x. This is function notation. It means everywhere you have an x in the original function, you're going to replace it with minus x. So everywhere we have an x in the original function, we replace it with minus x. Now, minus x to the third means minus x times minus x times minus x. 3 minus signs multiply. You don't have to show this part. You can just, but I'm showing it to you in case you don't understand. 3 minus signs multiply together. 2 make a positive, so you have a negative. An odd number gives you a negative. And how many x's are there? 3, so it's x to the third. So to simplify this, we get x negative, the opposite of x to the third. And then we have minus a negative is plus x. Okay. All right, so I don't know what a box is. All right, don't print things while I'm lecturing, please. Okay. I can see if I started a lecture and you didn't have the notes out yet, but don't print. It's too loud. All right, we compare this. This is f of minus x. Is this equal to that? It's not equal to f of x. Because even though the terms look like they're the same, they have opposite signs. So they're not equal. So it's not even. Okay, and then we're going to check to see if it's odd. It can only be one of these three things. It's either even, odd, or neither. It can't be two of those. So we're going to check to see if it's odd. Now we have f of minus x. Let's find the opposite of f of x. The opposite of f of x equals the opposite, and you have to put this in parentheses, x cubed minus x. And all you're going to do is distribute that negative sign. So we're going to distribute this negative sign and we're going to get negative x cubed plus x. You got that? Does this equal that? Yes, so it's odd. If those were not equal, then it would be even. Okay? One thing about odd functions is they all, if we have all odd exponents, it's going to be an odd function. And if we have all even exponents, it's going to be even. But so I need you to show your work on the test, though. So this is going to be an even function. But this is practice and actually showing with the definition. So we're going to check for even first. That's the easiest to check. Find f of minus x. Everywhere you have an x, you plug in minus x. And a constant term would have x to the 0 power, or 1 there. So this is going to be an even function. When you take negative x times itself, you're going to get positive x squared. So you're going to get 2x squared. When you take a negative x times itself 4 times, you got 4 negative signs that cancel out. You get x to the 4th plus 1, and that does equal f of x. So this is even, and you can stop. So first you check for even, then you check for odd, and then if it's not even nor odd, then it'll be neither. But if it's even, you can stop. Any questions on that? Are you following it? Okay. All right. And the graph of an even function is symmetric with respect to the y-axis. And the graph of an odd function is symmetric with respect to the origin. So we're going to graph these and show them to you on the calculator. TI 8384 is required for this class. I do let you use the calculator that's on your computer. There's a calculator on your computer. If you didn't bring one, just double click on it. It should come up. Okay. Are you gonna take off your internet? Okay. All right, so we're gonna graph the function on the calculator. So you can bring up the calculator from your computer. You clear out the home screen, you press y equals, clear that out. If there's any plots on, like I just turned one on, that's statistics plot, you'll arrow up there and hit enter to make sure it's not highlighted. And then you're going to put in, the function was x cubed minus x. So we're going to push the xt theta n button, caret 3, that's x to the third, minus xt theta n. There's our function. We can do zoom 6 for zoom standard. And that was an odd function. It's symmetric about the origin. Symmetric about the origin means you can flip it, take half of it, and flip about the x-axis, and then flip it about the y-axis, and it lands on itself. Okay? Flip about this half, if I take this half, flip it about the x-axis down here, and then the y-axis, it lands on itself. So that's origin symmetry. Put in the other function in, we get 2x squared plus x to the 4th plus 1. Graph. And that is symmetric about the y-axis. It means you can flip it across the y-axis and it lands on itself. Okay, so we saw that symmetry. Alright, and we're going to do piecewise functions now. This is the worksheet that's due Friday, piecewise functions. So, a function that's defined by 2 or more equations over a specified domain is called a piecewise function. So we're going to evaluate each piecewise function at the given values of the independent variable and then graph the function. But we're really going to make 2 tables of values. And we've got, okay, we can fill in what these are first. So here's the function, it's piecewise. G of x is equal to the linear equation 3x minus 2 when x is less than 0. And it's equal to the linear equation 2x plus 4 when x is greater than or equal to 0. So this is our defined one. The left side is less than 0, the right side is greater than or equal to 0. So we want to find g of negative 2. Well, negative 2 is x. So which definition are we going to use? Well, is negative 2 less than 0 or greater than or equal to 0? Well, negative 2 is less than 0. You don't have to write all this on your paper. So we use y equals, we have to use 3x minus 2. You only use that one because x is less than 0. Don't use both. You don't use both definitions because this is x and it's less than 0. You're only going to use that. So this is 3 times x minus 2. And I just put a parenthesis, fill in what x is. And then I do the math, and you can check with your calculator. 3 times negative 2 is negative 6, minus 2 is negative 8. So the point negative 2, negative 8 is on this graph. And you know, on your test, I might have a problem where you just have to find the function at some point and use the right one. And then I'll probably have one where you have to graph it too. G of 0. So is 0 less than 0? No. So you have to use this definition. So you have to use 2x plus 4 is 2 times x plus 4. And that's 0. X is 0. And that's 0 plus 4, or 4. So we still had to use, for 0 we had to use the second definition. For G of 3, that 3 is greater than or equal to 0, so we have to use y equals 2x plus 4 again. 2 times 3 plus 4 is 6 plus 4 is 10. So the point 3, 10 is on the graph. But we can't just graph these points and connect the dots. You could graph this line and erase the part that's greater than 0. And you could graph this line and erase the part that's less than 0. But you have to notice where the function is changing. And this is where this function is changing. It's changing at x equals 0. It doesn't have to change at the same place. And I did figure out that my StatLab does switch these up a little bit, but they're usually defined this way, but they don't have to be. They could have the equal part up here. So you have to put in 0 here to find the open circle. Where does this line begin? We're going to put an open circle, meaning we don't include the endpoint where you put 0 in. If you put 0 in here, you get 3 times 0 is 0 minus 2, you get negative 2. This is your open circle. At 0, negative 2 is an open circle. Your closed circle is going to be where you put 0 in here. And that's 0, and we already figured that out, 4. So we make a big closed circle up here. And it's on the line, it's where x equals 0. Okay, but I recommend that you make 2 tables of values. We're going to do the left side over here, a table of values. Okay, x and y. The left side is when you have x is less than 0, you'll be using the definition y equals 3x minus 2. Okay, so you put the 0 in, but it doesn't mean this is g of 0. It's not g of 0. 0 is only defined down here. This is going to be your open circle. That was negative 2. I'll just write open. And then you have to go down from there. So you can choose negative 1. When you put negative 1 in, you get negative 3. Minus 2 is negative 5. This is just a point on the graph. It's not an open circle. The open circle and closed circle occur where it's changing only. And then at negative 2, we already found that one, was negative 8. That's the left side. Let's do the right side. I'll do it over here. That's where x is greater than or equal to 0. So And when that's the case, we're using the definition y is 2x plus 4. Make an xy table. We have to start at 0 where it's changing. That's the closed circle. We found that was 4. And then we go up from there. We can choose 1. If you put 1 in for x, you get 2 times 1 is 2, plus 4 is 6. And we already put in 3, we can use that one. That's 10. And these better be straight lines, but separately. This is a straight line, and this is a straight line. So do it, graphing the left side, 0, -2, -1, -5 is just a point, so we make a little dot. -2, -8 is a point, and then you can take a straight edge, or I can draw pretty straight. Okay? And that's the left side. The right side, 0, 4 is a closed circle, 1, 6 is this point, 3, 10 up here, and that goes like this. And there's your piecewise function. Okay. So make 2 tables of values. If it just asks for these, you can find those and show your work, but it's going to make more sense to make 2 tables of values. Okay? And we got another one, another example. Any questions on that example? Have you seen these before? Some of you have? In 1100? Okay. Well, we got another one. This time it's changing at -1. So if we just go ahead and make our tables of values, our left side, less than -1, is going to be, x less than -1 is going to be y equals x plus 2. But it's only defined for less than -1, but we're going to plug in the -1 to find the open circle. Because the graph is defined at -1.0001. So we got to have an open circle on the graph to show it doesn't include the -1. Put in -1 here and you get +1. And you have to go down. So we may as well pick -2. And if we do -2, it's -2 plus 2 is 0. And we can do -3. Put in -3, you get -1. Do the right side. So when x is greater than or equal to -1, we have to use the definition y equals 3. That is a horizontal line. So if you do an xy table there, it means since there's no x's in the function, you've got a 3 no matter what x is. Y is always 3. But it's only defined for greater than or equal to -1. So -1, that's your closed circle. This was your open. So you always start with where it was changing. And if it's less than or doesn't have the equality sign, that's the open circle. And this is the closed circle because it has an equality sign. And then we want the point 0 and the point 3. And these equal 3. Alright? And then we're going to graph that. So this time it's changing on the line -1, x equals -1. So -1, +1 is open circle. Negative 2, 0 is a point. Negative 3, negative 1, and it just keeps going like that. Slope is 1. That's the left side. The right side, negative 1, positive 3, 0, 3, 3, 3, and that's a horizontal line, and it starts here at this closed circle. And there's our function. So that's the way you should do those. And the last page of this section, and we'll take a break then. Oh, that's what I did. Okay, and I changed this page since last semester to add a simpler example. So this is a difference quotient, and there is one of these on the test. So a difference quotient this is just slope. We call it a quotient because it's a fraction, we're dividing. But it is just slope. If we have a function here, and we have 2 points here and here, and this is x, and this is x plus h. So this little distance here is h. And then this is going to be f of x on the y-axis, and right here is f of x plus h. So if we make a straight line between these 2 points, we want to know the slope of this line between these 2 points. The slope is the change in y, f of x plus h minus f of x divided by the change in x, and that's h. So this is the slope. And then in calculus, we'll take that. This is a hard way to find derivatives in calculus. We will find the difference quotient and take the limit as h goes to 0, and we'll find the instantaneous slope of an equation that's not linear. So this is called the difference quotient. Of a function f. So we're going to find and simplify the difference quotient. So this is the difference quotient. You'll be given that formula on the test. Don't have to memorize that. We have f of x. That's in the formula. H is just h. And we just need to find f of x plus h. In order to plug in and solve this formula. So we have f of x, so we need to find f of x plus h. Well, that just means everywhere you have an x, you replace it with x plus h. So you leave space for x plus h there where there was an x, and we're going to put in x plus h there. Then you're going to distribute. So f of x plus h equals minus 3x minus 3h minus 5. Now we have everything we need for the difference quotient. So let me write down what it was. F of x plus h minus f of x divided by h equals. All of this is f of x plus h minus, we have to put parentheses around it, what f of x was. And all that is divided by h. So this is our f of x plus h. And this is our f of x. And that's the difference quotient. So we're going to distribute. And we're going to combine like terms in the numerator. Minus 3x minus 3h minus 5 plus 3x plus 5, and the 5's cancel, the 3x's cancel, oh, and you're dividing by h, so you get minus 3h divided by h, and the h's cancel, so the answer is minus 3. Okay? So now we're going to do a little harder one, but, so, we have f of x, we need to find f of x plus h. F of x plus h equals minus 2x plus h squared minus x plus h plus 3. Everywhere we have an x, we're replacing it with f of x plus h. Now if you need to go off to the side and FOIL this, you know, x plus h squared is x plus h times x plus h. That's first is x squared, x times x is x squared, and then you have your outer is hx, plus your inner is hx, and your last is h times h, or h squared, and everything was positive. So that simplifies to x squared plus 2hx plus h squared. So you can take this and put it in for that. And you do not distribute, you have to follow your right order of operations. Please excuse my dear Aunt Sally, exponents before you multiply. So we're following, please excuse my dear Aunt Sally, parentheses, exponents, multiplication, division is actually left to right, and addition and subtraction is actually left to right. Okay, so we cannot distribute the minus 2 before we square this. Exponents before multiplication. So this is minus 2 times x squared plus 2hx plus h squared. And we'll distribute the minus sign in here. And you get minus x minus h plus 3. Then we're going to distribute the minus 2 here. Every term has to be multiplied by minus 2. So it's minus 2x squared minus 4hx minus 2h squared minus x minus h plus 3. Okay, now I'm going to show you a little trick. If we take all the terms that don't have h's in them and resort them, we're going to put them all together up front. This doesn't have an h, this doesn't have an h, and that doesn't have an h. We're going to move those terms up here. Minus 2x squared minus x plus 3. And then we'll just write the other terms down. It doesn't matter the order. There we go. We got all the terms written down. And so this is a little trick. What is this equal to? This is our original function of x. This is f of x. So we have our f of x plus h equals all that. Okay? Now we're going to write our difference quotient. Our difference quotient is f of x plus h minus f of x, all divided by h. So instead of writing down these individual terms, let's just put f of x here. Here's what f of x plus h is: f of x minus this, minus this, minus this. And this is just, you don't have to do it this way, but you're less likely to make a mistake. Okay, so all of this that I just wrote down is f of x plus h. Now I need to subtract f of x. Instead of writing down what it equals up here, I can just write f of x. It will always work this way. And then we divide by h. Well, f of x minus f of x is 0. These cancel. So you kept yourself from having to distribute and put parentheses, and you probably kept yourself from making some mistakes doing the shortcut. And now I'm going to factor out an h. So h times minus 4x is this term, minus 2h minus 1. When you factor an h out of h, you get 1. H times negative 1 is negative h. And then I'm going to divide by h, and those cancel. So our answer is minus 4x minus 2h minus 1. That's our difference quotient. And now if we wanted the derivative, we take the limit as h goes to 0, and our derivative is minus 4x minus 1. But we just want the difference quotient. And that's the slope. And as we make h go to 0, it's an instantaneous slope at one point. Okay. All right, that's the difference quotient. Any questions on that? Did I lose you on this part? No. You may have to look at it. All right, we're going to stop the recording there. That was 1.3, right? Yeah, we're going to do 1.4 and 1.5. When we stop, if you need to print something, you can.